All right, so this is lesson 4.8, coordinate proof. Go ahead and try this first part, the warm-up, using the distance formula. So that's off to here, the side here to help you simplifying DE, since it's already written in there for you, and then doing EF, FD, GH, and HI. So go ahead and try that, and then press play to check your answers. All right, so go ahead and check your answers, and then you can see by side, that the triangles are congruent, so then we can finally prove those angles DEF and GHI that are corresponding. Those are congruent by CP/CTC. Since we have congruent triangles, we can use CP/CTC. So that's kind of a review of some of our previous lessons. All right. I missed something here down at the bottom. All right, so strategies for doing coordinate proof. We want to use the origin as a vertex. We're going to center the figure at the origin. So right here, kind of at 0, 0. And then center side of the figure at the origin, and then use the axes as sides. So we're using these axes as much as possible, as well as the origin. So what we're going to do is we're going to label a right triangle. So we're going to make this our right angle. Again, this being a side and this being a side, those being our legs. And then let's go ahead. I'm going to use and then we're going to go from there to there. So we're going to have, like, this would be 0, and then whatever our distance is up on the y-axis, and this would be our distance on the x-axis, and then 0 for our x, z, and then our y coordinate point right there. Okay. So legs D units long, we're going up D, we're going out D, and that's what that would look like if we centered that figure at the origin. So we're going to name the missing coordinates of the isosceles right triangle. So, well, it looks like this right here, if it's at the origin, then that should be 0, 0. Over here, we're going out to C, so it looks like this leg is C, which if we're going out to C, then we know that this right here, this x value has to be C, and then we're going up C as well for our height there for QRS. So this would be CC, and then this one's already labeled, and then 0, 0 for our Q at the vertex. So you're going to kind of see that pattern as we work through some of these problems. All right, so we're going to do basically what we did on our warm-up here. Let's go ahead and plot our points, and then we can use the distance formula. So go ahead and try this now, plotting all of your points, and then we're going to be using our distance formula, basically our warm-up here. So try this, and then if you need a little bit of assistance, I'll kind of work through it here in steps. All right, so first step, we're graphing DVW and PLM. So those two triangles, graph those. And then we're going to use our graph, and we're going to use our distances here. So let's go ahead and go through and kind of simplify using the distance formula. Double negatives change. And then we have 4 squared plus -1 squared. So that gives me 16 plus 1, which is 17, so the square root of 17 for that one. And then we're just going to go through and use the distance formula on all of these. So from V to W, and again, you could almost even just use Pythagorean theorem if you're wanting to, since you have a graph, but let's go ahead and practice continuing using our distance formula. So -7 minus negative, which turns into a double negative. -4, again, double negative, and so that gives me -6 squared plus -2 squared. And again, these are in parentheses, so make sure you do that in your calculator, because when we square something, it should be positive. So we have the square root of 40. So go ahead and do the rest of these, and I'll put the answers up there so you can check. And All right, so now we can see that we have these being congruent. We have our square root of 17s there, and then we have our just our corresponding sides matching up. So it looks like then that we can use side, side, side to show that our whoops, and WD should actually be 13, my bad. I was like, where's our square root of 13? But that one, I think I got that in the wrong spot, but that is the square root of 13, which then matches our last side there. So all the sides, triangle DVM is congruent to triangle LPM by side, side, side. So we can use the distance formula to kind of prove that. So on this next example here, we want to prove that the segment joining the midpoint of the two sides of an isosceles is half the base. All right, so let's go ahead and take a look. X, if we kind of did our midpoint formula there, would be a 2a plus 0 divided by 2. And then the y-coordinate would be 2b plus 0 divided by 2. So we're just using these points right here to find the midpoint, what x would be. And so x is equal to a, b, if we simplified, because that would divide, give you just a, that would divide and give you just b. And then for our y, let's find its midpoint. So we're going to add up our two x's here, so 2a and 4a, and divide by 2. And then we're going to add our two y values, 0 plus 2b, and divide by 2. And so that's going to give us 6a divided by 2, which is 3a, and then here 2b divided by 2 is b. So there's our y-coordinate. And so xy equaling 1/2 AC is what we're trying to prove. So let's go ahead and use the distance, and 1/2 for the distance of AC. So xy's distance, we're going to use its parts and do the distance formula. And so using its coordinates, we end up here with that ends up being 0 squared, which is 0. So here that's 2a squared. And then that ends up giving you just, 4a squared, and then we do the square root, which ends up just giving you 2a. And then over here, 4a minus 0 squared plus 0 minus 0 squared. And again, our 1/2 just kind of going along here. And 4a squared, and then 1/2 square root, so 16a squared. And so 1/2 of 4a is 2a. So 2a is equal to 2a. Perfect. And there it is. All right, so down here, this next one, we're going to write a coordinate proof. Let's go ahead and start what's given, and then what we're trying to prove. And then we'll kind of step in with all of our details here. So given W is the midpoint of XZ, and then we're going to try and prove that WY is perpendicular to XZ. So W, if we do its kind of midpoint here like we did up above, we would get 0 plus 2a over 2, which is just a. And then here, that's just going to give you 0. And then the slope, let's go ahead and look at slope for XZ and slope for YW so that we can then look for perpendicular. So for slope of xz, it's 0 minus 0 over 2a minus 0. So again, our slope formula, y2 minus y1 over x2 minus x1. So we're just using our slope formula here. So 0 minus b over a minus a. Negative b over 0, well, that's undefined. Undefined. And then this one over here is going to be 0 over 2a, which is 0. So this is horizontal, and this is vertical lines. And we know that horizontal lines are perpendicular to vertical lines. So YW is perpendicular to XZ. All right, so for our last one, go ahead and fill in 1. We're actually going to have kind of a 9 and a 10 here. So 10 is going to be our last, what we're trying to prove there. So go ahead and try as much as you can, and then we will kind of talk through this after you hit play. All right, so I'm just going to put my answer key up here. So here's our givens. I went ahead and put 1 and 2 as my givens. If you had them all on 3, then technically you'd have one less step. But then we want to go to from perpendicular here to perpendicular of 2 parallel lines, then it's perpendicular to the same line. So we can go ahead and do perpendicular on the other side. So then we know by definition of midpoint, taking step 2 and putting those 2 segments congruent. And then reflexive, we can go ahead and do BC, this one sharing its side. So it's like 2 triangles laying down and sharing BC as that leg. And then we have vertical angles, so we can go ahead and do those. And then by side angle side, we can prove the triangles congruent. CPCTC can get us angle A and angle D, so up here and up here. And then we can prove the triangles we're really trying to get to, ABC, congruent by angle side. And then finally, the big triangles there, AC, the hypotenuse there is congruent to that hypotenuse by CPCTC. So sometimes we need to have a few additional steps, but again, good to see some harder examples, because what you're going to come across on a test or a quiz would be shorter, a little bit more simplistic examples, but good to try these and kind of see that flow.